Support handout number 16. Problem 1, we want to give exact answers to each of these things. In letter A, it looks like I should start by going ahead and actually multiplying 2 times pi over 6. Of course, I have some cancellation that happens, which means really this is just sine of pi over 3. Hopefully you've got that value in your head. It's just square root of 3 over 2. Of course, if I need to, I can draw a quick 30, 60, 90 triangle. Pi over 3 is just 60 degrees. And of course, there's my root 3 over 2, opposite over hypotenuse. Letter B. Remember that squared there means that the entire trig ratio is being squared. This is cosine pi over 4 all being squared. Well, again, cosine pi over 4 I can get from a quick picture. It's just the 45, 45, 90 triangle. Cosine pi over 4 is 1 over root 2. We usually rationalize that, although I think in this case it's not really necessary because I'm just going to square the pieces. 1 squared is 1, and root 2 times root 2 is just 2. And so the final answer here is 1/2. Letter C is kind of like part A. I need to simplify the inside part there first. Dividing by 2 is the same thing as multiplying by the reciprocal of 2, which is 1/2. So pi over 2 divided by 2 is just pi over 4. And I can get that out of this same picture here. It is also 1 over root 2, although when we rationalize the denominator, we will get a final answer of root 2 over 2. Part D, again, remember those squareds mean the entire ratio is being squared. So first I have sine pi over 6 being squared. I can actually get that from this picture here. Pi over 6 is 30 degrees. And from the standpoint of that angle, the opposite would be 1 and the hypotenuse would be 2. So sine pi over 6 is 1/2. I'm squaring that. Cosine pi. Pi is quadrantal, so a unit circle picture would be appropriate. I'm right over here. This is the point -1, 0. Cosine gives me the a, the -1. And again, that is being squared. Well, 1/2 times 1/2 is 1/4, and -1 times -1 is +1. So all I have left is to add those two numbers together. I'll think of +1 as 4/4, so that I can add this together for a final answer of 5/4. Part E, once again, I have sine pi over 6 squared, so there's that 1/2 squared again. And then I have cosine pi over 6 squared. Once again, I could get that from right here with reference to that angle. Cosine would be adjacent. That would be the root 3 divided by the hypotenuse, which would be 2. So this is going to be root 3 over 2 all squared. I have that 1/4 again. And then let's see, root 3 times root 3 is 3. 2 times 2 is 4. I have 1/4 plus 3/4, which is equal to 4/4. In other words, 1. Finally, letter F, 3 times pi over 4 would just be 3 pi over 4 when I simplify that. I can draw a quick picture in order to work that out. Let's see, 3 pi over 4 is over here in the second quadrant. The reference angle would still be 45 degrees, so I have my usual labeling. This one here would be negative in the second quadrant. And so tangent is opposite over adjacent, 1 divided by -1, which is -1. Problem number 2. Sine theta is equal to 2/5. Theta is a quadrant 1 angle. I want to find the exact value of each of these items. Letter A, sine squared theta. Again, don't forget what that means. That means take your sine theta ratio and square it. Well, I was given my sine theta ratio. It's equal to 2/5. When I square that, I get 4 on the top and 25 on the bottom, 4/25. Letter B looks like just a straight substitution. I'm going to replace the sine theta with 2/5. I'll think of that 1 there as 5/5. 5/5 plus 2/5 gives me 7/5. And all that's left now is for me to do a little bit of simplifying here. I'll split this into two radicals, root 7 over root 5, and then I'll rationalize the denominator. And it looks like the final answer is root 35 up top and 5 on the bottom. How will I get cosine theta in part C? Probably the fastest way is just a quick picture. I know I'm in the first quadrant. I know that the sine ratio for angle theta, here's angle theta, is 2/5, so 2 over 5. To get the cosine ratio for angle theta, I just really need that third side. I can get that third side using the Pythagorean theorem. A squared plus 2 squared equals 5 squared. A squared plus 4 equals 25. Looks like A squared is equal to 21. And when I square root, I don't need to worry about the plus or minus. I'm in the first quadrant. This side then is square root of 21, which means cosine theta is root 21 adjacent over 5, hypotenuse. Part D, 4 cosine squared theta minus 1. Well, now that I know cosine theta, I can simply substitute that in. It might help me to write this the long way, just to remind myself what it is that I'm actually squaring. I'm squaring the cosine ratio, which was root 21 over 5. So that's what's being squared. I'll square it, I'll multiply it by 4, and then I'll subtract that 1. Let's see, root 21 times root 21 is just 21, and 5 times 5 is 25. As far as working this out, I don't have any cancellation in that first multiplication, so I can just multiply across. That would be 84 25ths. And then for the 1, I should write that as 25 25ths. 84 minus 25 is 59, and there's my final answer, 59 25ths. Letter E, looks like just some substitutions here. I have the number 50 times the sine ratio, 2/5, times the cosine ratio, root 21 over 5. I do have some canceling this time. 5 times 5 is 25, and that 25 will go into this 50 twice. I don't even have any denominators left, so the final answer here is just 4 root 21. That 2 times 2 makes the 4, root 21 in the square root, and I'm done. What about letter F? Letter F is asking me, well, what is theta itself? I have a picture of it right here. Obviously, I could go to the calculator and get a decimal approximation, but that's not what's being asked here. I want the exact value. This is not one of our special triangles, so the best I can do here is start with a trig ratio like sine theta equals 2/5, and then say, well, I know since I'm in the first quadrant that theta is just going to be sine inverse of 2/5. We are making the assumption that theta is between 0 degrees and 90 degrees, but here would be the answer, sine inverse 2/5. Problem number 3, we want to express each given angle as half of another angle. When you hear half of in math, the of is always multiply. So I'm really just thinking here, what would I have to multiply by 1/2 to get pi over 8? And of course, it's pretty simple. It would just be pi over 4. If I multiply across, 1 times pi is pi, and 2 times 4 is 8. So pi over 8 is half of pi over 4. We can just use that same logic in these other problems. Here, I would have to use 5 pi over 6. And if I multiplied across, I'd get 5 pi over 12. And for 7 pi over 8, I would have to use 7 pi over 4. And again, if I multiply across, I would get that 7 pi over 8. Another way we could have done this problem is to take the given angle and simply double it, multiply it by 2. And if I did that, I would find the angle that I wanted, in this first case, pi over 4.